Okay, welcome back. At this point, I wanted to start a section about integration by parts. And this is just part one. There's going to be several parts to this. And in this video, I want to just cover the fundamentals about how the technique was derived and very simple examples just so you understand what's going on. So at this point in your calculus curriculum, you've gone through, you know, derivatives, you went into antiderivatives for a handful of functions on the antiderivatives. You may or may not realize that there are limitations to what you know as far as how to do an integral. This is going to move you significantly forward as far as being in your toolkit for being able to do an integration for anything. Also, you've probably done integration applications such as area under a curve or volumes or work calculations. And if you notice in those calculations, you've set up your integral, and many times they just say, okay, that's good enough, or the integral is really simple and it's easy for you to move through. But problem is the real world is not that simple, and it's going to get more and more complicated for you. So anyway, so we have, if you realized, you might have run into places where you realize you can't solve certain things. But hopefully this gets you there. So let's talk a little bit about what is the integration by parts. Well, the foundation for it really starts with, if you go back to solving derivatives, and if you have function x and function g of x, those two, if you want to find the derivative of two functions multiplied together, you have to use the product rule. So, and that would say the first function, f of x, times the derivative of the second function, plus the derivative of the first function, times the original first function. So if you look at that, let's just take the integral of both sides. F of x, g of x. And if you remember in the product rule, you get to choose what's f of x and g of x when you get to real problems. And then f of x, g prime of x plus f of x prime g x. Okay, so I'm going to take it very slowly, step by step, so you can understand exactly. If you look at the textbook, they do a pretty good job, at least the one by James Stewart, I think is the author. Does a very nice job of walking through some this, but there's some gaps that if you're not as savvy, that's where I want to try to help you out. So obviously if a derivative, the integral of a derivative, that's just going to go right to f of x, g of x. And then we're going to split, because we have, this is a bracket around everything. We're just going to split the integral. Next step, f of x, and there, oh, I always forget that. dx plus f of x prime g x, this should be an integral, and dx. Okay, so next step is to move this guy to the other side of the equal sign. Okay, so essentially I'm going to have f of x, I'm sorry if I'm going really slowly, minus f prime x g x dx equals we're almost there. Okay, so now really if you look at it, this is the guy that you're going to start with. And you'll have to choose what is your f of x and what is your g prime of x. And then from there, you have a means to separate things out and perform an integral. So really you're going to end up, I'm going to switch these because I like to have what you start with on this side. Fx g prime x dx equals fx gx minus integral f prime x gx dx. That is a very, very important equation right there. So let me write this a little better so it doesn't look like an S. Okay, so you're going to start off, and there's decisions to be made when you get a problem like find the integral of x times cosine x. Well, you haven't really done that yet. You haven't figured out a method for figuring that one out. Integration by parts will let you get there. But what you have to do is you have to make choices at this point. You're going to assign certain values to f of x and to g prime of x. If you look over on the other side of the equal sign, you do need to take the integral of g prime to get just plain g of x. And then you take f of x, plugs in here just as is. And then you take the derivative of f of x over here. So the whole point behind this is to make sure that this integral that you have left is not more complicated than the original integral here. So if it's easier, hopefully you get to the point where you have something simple that you know the antiderivative for. And so if I select well, I will be saying that f of x equals x and g prime of x equals cosine x. So then let's see if I have enough room, g prime of x equals 1 and g of x equals sine x. And I'm not going to worry about plus c's and things in there just yet. We'll have to remember that at the end. So therefore, if I have the original formula here, I can go, my f of x is x times sine x minus f prime of x is just 1 times g of x, which is sine x dx. Well, we know the antiderivative of sine, right? So we can easily just say the answer for this one is x sine x, and it's going to be a negative cosine is the antiderivative here, so it's going to be that negative and the negative on the cosine is positive cosine x plus c. So that is your answer for that integration here. So question would be, well, what happens if I select f of x equals cosine x and g prime of x equals to x? Well, then g of x would equal 1/2 x squared, and you can start to see that you wouldn't end up with anything simpler on this side here in this term. So things would start to get ugly. But actually, if you do it right, it will work itself out, because you'd have to do what typically happens in integration by parts is you have to keep on doing this over and over. Like, you get to here and you've whittled out some of the complexity, and then you have to do another integration by parts and another integration by parts and so on. So that's typical. So this is where I'm going to stop for part 1. Keep an eye out for part 2, where I'm going to add a little bit of complexity. There's some tricks in there as well. But it is a really powerful tool, and it actually is something that's really worth mastering. So subscribe to my channel. There's a link somewhere on the site. So you can easily find where part 2 is and see when I put it out there. And I'm sure there's probably going to be part 3 and part 4, because this gets more and more challenging. Then we add trigonometry in there. But at the end of the day, you're going to have something under your belt that really works well. So good luck. Hope this helps.